G'day team, welcome back to another video. So hopefully you've watched the introduction to periodic functions because that's going to set up a bit of base knowledge for what we're about to hit today. So today we're actually going to look at the general sine function. So what I want you guys to do is go to Desmos and input y equals a multiplied by sine times by bx takes c plus d and add the sliders. And then I want you to change values for a, b and c and d individually and observe the effects each has on the function. So I've actually gone ahead and done it. All right, so would be good if you guys played along at home, but it's really good to see this effect. So I've got my general sine function, I've got my 4 sliders in. So I've set it so a equals 1, b equals 1, c equals 0, and d equals 0. That is our most general sine function. It actually equals y equals sine x. Now, let's individually look at the sliders. So a actually changes how tall our function goes. Okay, so a is changing the amplitude. Now b is changing the period. All right, we're actually dilating our function. Okay. Now c, as you can see, is a horizontal translation. Okay. And then finally, if we're looking at D, which you could probably guess is going to be our vertical translation. All right. So it's really important to have those sort of facts down. All right. Back into it. So the general sine function. So as we saw, A affects the amplitude, B affects the period, C affects the horizontal translation, and D affects the vertical translation. So we actually have the period is equal to 2 pi divided by B. The principal axis, all right, the equation for that is y equals D. And then the amplitude is the modulus of A. So if A is -2, then the amplitude is just +2. All right. So this is the most basic sine function, y equals sine of x. So starting at 0, 0, moving equals 1 at pi on 2, equals 0 at pi, equals -1 at 3 pi on 2, and equals 0 on 2 pi. Now, if we compare that to our unit circle, which I can whip up really, really quickly here. All right, so unit circle, nice circle there, that's not bad. All right, remember these are the points, 1, 0, 0, 1, -1, 0, and 0, -1. Now, if we're following this around, so at this point, our x coordinate is 1, all right, but our sine value is 0. So at 0 degrees, our sine is actually 0. At pi on 2 radians, our sine is actually 1. All right, at pi radians, it's back to 0. At 3 pi on 2, it's -1, and back at 2 pi, it is 0. All right, so we're actually using the unit circle to periodically plot our sine x function. So one thing that will get you guys to do is to state the transformation or transformations which occur. So in this case, state the transformation or transformations which map y equals sine x to y equals 3 times by sine of 2x plus 2. Now, I want you guys to break it down step by step. We know that the A term is being altered, the B term, we don't have a C term in this one, and we have a D term. So going back up to our general function here and seeing what affects what. So A is the amplitude, B the period, and D the vertical translation. So we have a vertical dilation with a scale factor of 3, a horizontal dilation with a scale factor of 1 over k, which equals 1/2. So remember back to our translational work, scale factor horizontal dilation is 1 over k. And we have a vertical translation upwards 2 units. All right, that is all these questions will ask you to do. All right. Now, let's go through finding the equation of a sine function together. So we know a couple facts about this. We know this is the principal axis here. All right, so remember our general sine function, a times by sine of bx, take away c plus d. Now, looking at this, we can see that we have actually got a vertical translation. All right, so the vertical translation is where, so d, and then we also know that d is the principal axis, which actually occurs at -2. So we know d is equal to -2. All right, so y is equal to a sine bx take c take away 2. All right, all we're going to do is slowly just nail this down bit by bit. All right, so do we have a horizontal translation? So if we actually translated it back up to the principal axis being 0, then we actually haven't moved horizontally because we'll start at 0, 0. So that means we don't actually have a c. So I'm going to keep going here. So y is equal to a sine bx minus 2. So we've just dropped that c term out. Now, the period, all right, so if we're looking at the period is pi on 2 to 3 pi on 2, which is pi, all right, so it's a period of pi radians. Now, if we look back up here, the period is 2 pi on b, all right, so we've got period, which is pi, is equal to 2 pi on b, all right, so b is equal to 2, all right. Hopefully that is super clear for you guys. So y equals a sine 2x minus 2. And then y is equal to, now we need to find a, which is the amplitude, just how far up this is, which is also 2 units. So remember, it's the modulus. So even if it's negative, we still use the positive. 2x minus 2. And there you have it. That is the equation of our sine function that we have graphed here. Now, I want you to follow those sort of steps and just do one bit at a time. No point doing it all at once, because that is when you make those silly mistakes. So I will see you guys in the next video when we start looking at the cosine function. Catch you guys next time.